We live in an era of conflicts, scarcity and energy poverty. While the world's powers fight over ships and pipelines, the solution is the sun, hitting your roof every single day. People often think that hydrogen is rocket science, and it is. But that doesn't mean you can produce it at home. It's even simpler to interface with a single PV than the fridge of last week. I'm not saying that you have to forget about natural gas tomorrow, but today we prove that common folks like you and me can make this fuel in full safety. The rules are simple and driving a car is more dangerous. To mention just one scary feature of hydrogen, if mixed with oxygen, the flame front has a speed of 8 times that of sound. But we will make the production intrinsically safe. In 2 ways. And it will be affordable. As a famous leader once said, yes, we can. This video, following the PV2com message, directly connects the PV to your hydrogen factory. Safe, simple and affordable. Plug and produce, no more excuse. Hi, I'm Norbert, energy engineer, and in video number 140 we continue our journey to the mysterious world of hydrogen, the father of all matter. PV2com means a direct conversion of PV solar to commodities, and it is a playlist that I am building now. There are many videos about hydrogen generators and applications. I saw many good videos, but wanted to connect it to a PV panel directly. I realized that this is possible, and thus found a direct drive innovation. Remember the solar fridge project of last week? That required about 70 euros in 2 interface devices. Here, we don't need a battery or an MPPT optimizer. We are plugging the PV panel directly into the electrolyser. The electrical characteristics of the process allow that. It's a pure plug-and-play solar factory. It's also safer than many other systems on videos, and you will see that later. If you want, you can add MPPT and battery. It has its advantages. Think of H2O like 3 Lego pieces, tightly stuck together. Sunlight provides the chemical wedge to pry them apart. Even stable water has molecules living apart, much like married couples with one half on business trip or visiting family. See the short discussion at the end of the video. If you find this solar fuel factory concept exciting and you want to see another example of a solar island come to life, hit the subscribe button with notification. In this playlist, I try to make a commodity production unit in many different ways around just one PV panel. I ordered the simple materials to make one, and I am sure you want to see next week how I built my own home factory. Now, why go through the trouble? That's because hydrogen is the father of matter and has some very interesting features. Cooking. A clean flame, but also very hot. Conceal it under pebbles to spread the heat and hide the UV radiation. Metalworking. Our 2800 degrees Celsius torch for precision welding is able to make holes or cutting. Heating. Injecting energy directly into your home system. Try to find heating applications for the summer, when the sun is stronger. Glass blowing. Melting sand into fused silica or quartz, or working borosilicate glass like Pyrex without any soot stains. Artists are using this for high purity quartz. You can also make holes in glass bottles. Electricity storage. You can using it in a fuel cell later. Thou, be mindful of the 24% to 48% round trip efficiency. The electrolysis is a more efficient step here. It's the fuel cell where more energy is lost. Transportation. Fueling small hydrogen converted engines on combustion or vehicles with fuel cells. Fertilizer. Creating ammonia for your garden. Metal repair. Unrusting old iron by using the hydrogen to reverse oxidation. And then you need a flame with too little oxygen. Zero emission backup. Silent clean power for emergencies. But remember that hydrogen finds the smallest escape routes and penetrates even common materials like PET bottles. So 48 hours is the maximum period, depending also on the pressure. I think that is already a good medium-term storage. Synthetic natural gas. Combining hydrogen with CO2 to create methane through the Sabatier process. This lets you also improve biogas, which is methane with 40% CO2. That these applications can be safe, you will see now in a moment. My setup uses an 8-couple series to match the 17 volt of a single PV panel. I would like to use a bottle-in-a-bottle coaxial design, but maybe it's more practical to create 8 bottles of 2 liters and 8 bottles of 1 liter next to each. I will put them in series, and because of the volt to current graph, the panel and the system are well matched to each other. A cloud in the sky will just stop the production, nothing else. And now about safety. Is it dangerous? Well, driving a car is more dangerous. We keep the gases separated from the start, just like keeping Stan and Laurel separated. As you know, that's the best way to avoid trouble, which is much safer and removes the need for flame arresters. Only the last moment they are mixed together and never in a confined space, only in open air, where the flame is created. We have also an automatic cutoff. If we forget the system and the sun is shining, the gas pressure pushes the water level below the electrodes, breaks the circuit, and the factory stops itself. That will avoid that the bubbles can escape from the bottom of the bottle and mix with the other gas. A warning: this flame is invisible and extremely hot. Use welding or strong sunglasses to protect against UV radiation and flying fragments of molten metal. Pieces of stone and glass can explode because of the thermal shock. The mixture of H2 and O2 is very explosive, so don't bring them together until the last moment when you are igniting, and only small amounts of gas. Open first the hydrogen and ignite. When you see the flame, only then also the oxygen valve can be opened. Next week will be the prototype day. Let's see how much hydrogen we can produce in one day for each 100 watts of nominal PV power. If you know that, write it in the comments. The sun is shining, stop, let it heat only your roof. Let's make the sun produce something. Every single panel should feed some microfactory, be it hydrogen or any other commodity. That is PV to come. Thanks for watching this deep dive into another PV to come possibility. After this conclusion, there is a bonus, a discussion about what exactly happens during electrolysis. If you like the video, please put your thumbs up, subscribe with a notification, and try to build one of my projects. See you in a workshop next week. Stay resilient and curious.
Usually when we think about breaking molecular bonds, we picture brute force, massive heat, extreme pressure.
Yeah, it's violent and really energy intensive. Forcing atoms apart traditionally requires a sledgehammer approach.
Right. But what if tearing something apart could be perfectly clean?
Precise, right.
Yeah, almost like pulling down a zipper. Welcome to today's deep dive. We're looking at a visual diagram of water electrolysis alongside some text on a concept called the solar zipper.
And the mission for you today is to really understand exactly how sunlight is used to literally unzip water into hydrogen and oxygen.
Okay, let's unpack this. The foundation starts with the solar panel, right? It essentially acts as a powerful pump, taking energy from the sun and shoving extra electrons into a stainless steel mesh.
Exactly. And that stainless steel mesh, now flooded with extra electrons, becomes the cathode. That's the negative side of the system.
Got it.
Now, water naturally has positive hydrogen ions just floating around, and they are instantly pulled toward the negative charge of that cathode.
In a magnet.
Right, exactly like a magnet. Once they hit the mesh, they essentially swallow those extra electrons.
Oh, wow. It's almost like they're catching a key that lets them break out of molecular handcuffs.
I like that analogy.
Yeah, suddenly they're free from the water structure. They snap off, pair up with another freed hydrogen atom, and just bubble up to the surface as pure hydrogen gas.
But remember, water is H2O. You've just ripped the hydrogen away.
Right, and you can't just, delete the oxygen. The moment those hydrogen atoms break out, it creates this, massive chemical imbalance in the tank.
What's fascinating here is that those leftover parts, which are now negatively charged hydroxide ions, or OH-, are instantly repelled by that cathode.
Because negatives repel negative.
Right, so looking at the diagram, you can actually see them travel through this middle barrier. It's a membrane the text calls a bridge hose.
A bridge hose, okay.
Yeah, they migrate toward the positive side to balance out the electrical pressure in the tank.
Wait, hold on. If they are moving over to the positive side just to balance things out, is this whole system just a giant sun-powered electrical recycling loop?
Think of it exactly like an electrical recycling loop. When those negatively charged hydroxide ions reach the positive mesh, the anode, they hand their extra electrons right back to the circuit.
Which makes them unstable, I assume.
Highly unstable, yeah. To fix this, they have to recombine. Let's look at the atomic math happening at that mesh.
Okay, I'm following.
So if you have 4 of these hydroxide parts, that's 4 hydrogens and 4 oxygens. To stabilize, the 4 hydrogens instantly pair with 2 of the oxygens to make 2 brand new molecules of liquid water.
Oh, I see. So that leaves exactly 2 oxygen atoms orphaned.
You got it. They lock together and boom, you have O2, breathable oxygen gas just bubbling up.
Here's where it gets really interesting. If you look at the visual diagram in our sources, the atomic math is literally showing up in the water.
Yeah, it's right there.
There are visually way more bubbles floating up on the hydrogen side than on the oxygen side, noticeably more.
Well, if we connect this to the bigger picture, it all comes down to conservation. We aren't creating new energy out of thin air.
Yeah, right. We are just using the sun's energy to unzip the water.
Exactly. The math is beautifully strict. For every 4 electrons the solar panel pumps through the system, you get exactly 2 molecules of hydrogen gas and only 1 molecule of oxygen gas.
So what does this all mean? It means this 2-to-1 atomic math is exactly why your hydrogen bottle will always fill up twice as fast as your oxygen bottle. The visual proof of the chemistry is bubbling right there in front of you.
It is just such an elegant mechanism. I mean, you are witnessing a totally clean process where sunlight simply slips in and unzips ordinary water into highly energetic fuel and breathable air.
Yeah, no sledgehammers required, just a perfectly clean break.
None at all.
Which leaves us with a final thought for you to ponder today. If a simple solar setup can so elegantly unzip water to unlock such powerful fuel, what other abundant, everyday molecules around us might just be waiting to be unzipped by the sun?